Hi Finance 3320 students. On this video I'm going to go over some of the problems that will be similar to what you would expect to see on an exam and what you would see in your homework. I just hand wrote some notes here. This is really duplicative of what you have in your book. So it's nothing new. But I note here to be aware at the bottom of 459, and I mentioned this in the other video, that pretty much we use required rate of return, appropriate discount rate, cost of capital. We tend to use those synonymously. Now, as far as our costs are concerned, we've got the cost of equity, the cost of debt, and the cost of preferred. The cost of equity can be one of two different models. One is the Gordon constant growth model, or often called the discount dividend discount model. But in my opinion, every model that uses dividends is a dividend discount model. But at any rate, Gordon constant growth model. And that just says that the cost of equity is equal to the next dividend, D1, and we typically do this on an annual basis, D1 divided by the current price, and this would amount to a dividend yield, plus G, and G is growth in earnings, growth in dividends, and ultimately growth in price. So that's the Gordon growth model version. It's common to use recent historical growth, but really what we need is longer-term growth for the future, not past growth. And this shows the bottom of 461 and the top of 462, but you probably recall that I put on the screen the other day, or in the other video, I put on the screen something that just gave an example of that calculation of the geometric mean for use in this model. The other version is the capital asset pricing model slash security market line. And again, the capital asset pricing model is the whole model. The security market line is the line in the model. And it just says that the required return on equity should be equal to the risk-free plus the market risk premium, which is RM minus RF, times the beta. So we need three pieces of information here, RF, RM, and the beta. And up here, we need three pieces of information, D1, P0, and G. Again, to remind you, probably what I will do on an exam is not tell you what D1 is. Instead, I'll tell you what D0 is. That is to say, the most recent dividend was, and you will have to know to multiply that times 1 plus the growth rate in order to get D1. And if you don't do that, your answer will be wrong. Cost of debt is the yield to maturity of existing debt. It's not the current yield. It's not the coupon rate. It's yield to maturity. The idea there is if the market is requiring a particular yield to maturity of you now, then when you sell new bonds, that would be a good starting place for what they will require from you on your new issue. If you don't have outstanding debt, then you might look in the marketplace for similar risk bonds or bonds of companies that are of similar risk. And for the cost of debt, because dividends are tax deductible, you would say that the after-tax cost of debt is the cost of debt times 1 minus the tax rate. And finally, we have the cost of preferred, and the cost of preferred is just equal to the dividend divided by the price. There's no growth in dividends, but as I think I noted on the other video, if you take preferred stock and you put it in this, well, you'd have a D1, but that's the same as D0 and D25 because they don't change. You'd have a growth rate, but the growth rate would be 0. So it would just be D over P0, which is what this is. So the weights are percentages based on market values. Emphasize market values. There is a problem that we're going to go over, and it does look at book values, but we're really concerned with market values. V is the total value of the firm, including the value of the stock, market value of the stock, market value of the bonds, and market value of the preferred. So what we're going to do ultimately is figure a weight for equity, which is equal to stock price times the number of shares. That's all it is, the market value of the stock, price times quantity. Same for preferred. And then for debt, depending on how the information is given to us, we could take the bond price in dollar form. So the problem might say bonds are selling for $960. And multiply that times the number of bonds to figure out, well, what's the total value of the debt. It could be that it's given to you that the bonds are selling for, let's just say, 95. Well, that means 95% of par. It doesn't mean $95. So if the bonds are selling for 95, then you multiply that percentage times the book value of the bonds. So if the balance sheet says there are $1 million worth of bonds and the current bond price is 95, then it'd be 0.95 times that $1 million, or $950,000. So we've already gotten these values, the value of the equity, the value of the preferred, and the value of the debt. We add them up to get the total value, and then we take the individual percentages. And that brings us to the weighted average cost of capital, which just says the weight of equity times its cost, plus the weight of preferred times its cost, plus the weight of debt times its after-tax cost. So here's an example, and sorry for my terrible handwriting, but what I would suggest that you do is to pause after I go over this part, to pause and try to do this yourself without seeing the answer. Or you can go ahead and watch it straight through if you want, but I will tell you, practice is, it may not make perfect, but practice certainly helps. So here we've got an example with a stock price of 60 and the dividends, and these dividends are given in historical order, starting from the most recent period and going backward. So this is D0, which is the most recent dividend, is $4.06. And let me see if I can get, I don't think I can get any closer. Maybe so. So this says $4.06. D minus 1 would be not last year, but the year before, and that's $3.90. And D minus 2 is $3.78, $3.70, $3.55, $3.50. There are 1 million shares. The beta is 1.2. Return to the market is 10%, and the risk-free rate is 3%. So what we have there is a price. We've got a D0, and we can calculate D1, but we have to get a G. But these pieces of information here we're going to use as part of our use geometric mean in order to calculate what that rate would be. So we have enough information for both the Gordon growth model and the security market line. Then we have preferred stock for $50 par value. If it says $50 par value, that is not what it's currently selling for. That's just what it's listed for on the books. And it's a $4 dividend. There are 100,000 shares, and it's selling for $40. Finally, debt. We have par value of $1,000 on the bonds. They're selling for $960. Again, that could have said that the price is 96. And And here it's saying there are 20,000 bonds, so we're going to multiply the 960 times 20,000. It could have said there's $20 million of book value of bonds, and the bonds were selling for 0.96. Either one would give you the same answer. Annual coupon is 5%. Time to maturity is 10 years, and the tax rate is 20%. So given that background and that information, I'd urge you to stop the video right now and start trying to work it. Okay, so let's go through and calculate the cost of equity. Well, the cost of equity is D1 over P0 plus G, but we need a G. And here's how we're going to get this, this G value. We're going to go from D0, which is $4.06, up to D, you can't see that. We're going from D0, $4.06, back to D5, minus 5, which is $3.50. So we have, in periods where we can compare, we have from D minus 5 to minus 4, that's 1, 2, 3, 4, 5 different possibilities for calculating what a rate of growth would be in each one of those periods, and we're going to take the geometric mean of them. So what we can do instead, and this is what we did on the other video, is we can take that most recent dividend and divide it by the one that was 5 periods before, take it to the 1/5 or 0.2 power, and subtract 1. So for 06 divided by 350 to the 0.2 power minus 1 is very close to 0.03. I think it's a bit off. Let me see if I can calculate. It doesn't look good. So I'm going to do it with future value and present value. And so I have 3.5 change signs as my would be counted as my present value because it's the one that occurs earliest, and then 4.06 it'd be my future value, and my n is 5, and compute my IY. Well, obviously I pushed the wrong button. We're going to try that again. We've got 4.06 is my future value, 3.5 change signs is my present value, 5 is my int, compute IY, and it's 3.0129, and I just, for this purpose, rounded it to 3%. If you're calculating a percentage and it comes out to be 16,000, then probably something went wrong, or else, well, probably something went wrong. Okay, so we've got 406, which is our D0, and we're going to multiply that by 1 plus the growth rate, so that gives us D1. D1 over P0, which was given as 60, plus G, which we just calculated as 3%, and that gives us $4.18 over 60 plus 0.03, which is, this is 0.0997, so pretty close to 10%. Or we could have used the security market line version, and the security market line version requires that we get the risk-free rate, which is up here, so 3%, and the market risk premium, or just the individual return of the market and the risk-free. Return of the market is 10%, risk-free is 3%, we already had it once, and we multiply the market risk premium by the beta, and the beta was given as 1.2. Multiply those together and we get 11.4%. So this one says just shy of 10%, this says 11.4%. And the book sort of implies that a reasonable thing to do would be to take some sort of an average of those two methods. For preferred stock, we just take the $40 price and the $4 dividend and divide them, and that gives us 10%. I should say again, with preferred stock, it could say, in this case, it could say it's a 2% preferred, 2% and 8% preferred, and that is $4 dividend divided by $50 par value. So the 8% relates to par value, not to price. So 4%, $4 relative to $50 is 8%. $4 relative to $40 is 10%. But it could say it's an 8% preferred, and if it says 8% preferred, it's based on par value. And now we go to debt. And that, of course, was Louis Louis by the Kingsmen from about 1962 or 3, I think. I don't know who that was. So the cost of debt, we're going to calculate the yield to maturity, and it was given to us up here as a par value of 1,000, a price of $9.60, and a coupon of 5% and a time to maturity of 10 years. So we have that information repeated here, and we calculate that yield to maturity. And I can do it on my calculator. Let's hope I can push the right buttons this time. So we've got 1,000 is our future value. Give me a second. I'm going to turn off this overhead light. Might be too much, we'll see. That's my future value is 1,000, and my N is 10, and my present value is 960. Change signs is my present value. So I've got recall N, I've got recall present value, recall payment. My payment is 50 because it's 5%. And recall future value. Now I'm going to compute IY, and it's 5.5315%. And to adjust it for taxes, I would just multiply by 1 minus the tax rate, and the tax rate was given as 20%. So I'm just going to multiply this by 1 minus 20%, which is 0.8, times 0.8 equals 0.0442, or 4.4252, really 4.43%. Now we're going to calculate the weights. Let me see, I might have to zoom out a little bit here. So we need to figure out what the values are of these individual sections of our cost of capital calculation. And for the equity part, we're given a stock price of 60, and we're given a number of shares of 1,000,000. So 60 times 1,000,000, 60 million. And for the preferred, we're given $40 price and $100,000 shares. So 40 times 100,000, 4 million. And for debt, we're given $960 and 20,000 individual bonds. So 960 times 20,000 is 19,200. And what I was saying before is this same problem could be set up the same way, and it could say that you have $20 million of bonds, and the current bond price is 96. And bond prices are quoted in the real world in percentages, not in dollar amounts. And for that 20 million at a price of 96, which really means, it's hard to see that 9, I think. When the price is given as 96, it's not given with a decimal here. Everybody knows that 96 means 96% of par. So if you're given the price as 96 and the total the total book value of the bonds is 20 million, that still comes out to 19,200. So what are the weights? Well, here's the sum of all three of these, and so the weights would be 60 million over this 60 million over 83.2, and that's 72.12%, and 4 million over 83.2 million, and that's 4.81%, and finally 19.2 over 83.2, and that's 23.08%. This comes off a little bit just because rounding error, and it's nothing to worry about. So now we need to calculate the weighted average cost of capital. I'm going to shuffle back and forth a little bit here, so it may seem a little confusing, but this is what we're going for here. And the first part, we're going to look at equity, and the weight on equity, I'm just going to leave this page here and then put the other one in front. The weight of equity is 0.7212. So we're going to multiply 0.7212 times whichever version I use in the problem for the cost of equity. So I might say use the SML version, because I'm going to have you calculate both. But I could say use the SML version, or I could say use the Gordon Growth Model version. And this one, I'm saying use the SML version. So the SML version was 11.4%. So we're multiplying 72.12% times 11.4%, and then we're going to go with preferred. Preferred has a weight of 0.0481, and it had a cost of 10%. So 0.0481 times 10%. And then debt. Debt is 23.08%, and the cost after tax of debt is 4.42%. So, well, here I've shown the cost of debt pre-tax, and then I've multiplied by 0.8, so you don't see the 0.442 version, but you know what's going on here. It's the pre-tax times 1 minus the tax rate. So we have to get this product here, this product here, this product here, and add them all up, and when we do, we get a weighted average cost of capital of 0.0972 or 9.72%. So that's an example. And now I'll look at the one that's at the back of the text, and this is going to be a little bit hard to see, but you have the text. So I'll zoom in here a little bit. And so here we have a problem. You have a company with a beta of 0.8. Well, that tells you right away that something in here is going to be asking for the SML version. The market risk premium is 6%. Remember, and the risk-free rate is 6%. So both the market risk premium and the risk-free rate are 6%. Now, what this means is the return to the market must be the sum of those. 6 plus 6 is 12. But we don't actually need to use that. last dividend was $1.20. The dividend is expected to grow at 8% per year. So we've got a G, we've got a D0, and the stock sells for 45. What is WADA's cost of equity capital? So here we show two different approaches. And this is the security market line version. And our risk-free rate was 6%. Let me see if I can get this on here. Our risk-free rate was 6%, and that was right up here. And our market risk premium was also 6%. That's up here. And our beta was 0.8, and here's the beta, 0.8. And we plug that in, multiply, add, and we get 10.8%. So that's the version 10.8 that we get using the security market line approach. If we want to use the Gordon growth model approach, well, we've got a growth rate of 8%, and we've got a D0 of 1.2, and we've got a stock price. So we've got what we need for D1 over P0 plus G. But what we have to do is calculate D1, because what we have is D0. So if D1 was $1.20 per share, D0 was $1.20 per share, then to calculate D1, we're going to take that $1.20 and multiply it by 1 plus the growth rate. And that gives us $1.296. And you do see tenths of a cent and some in dividends. So now we take that $1.296 and divide it by the $45 stock price, and then add the growth rate, and we get 10.88%. So one is 10.8, the other is 10.88. Okay, in addition to that information, WADA has a target debt-to-equity ratio of 50%. So debt divided by equity is 50%. And essentially what that means is there are 2 parts of equity for every 1 part of debt. WADA uses 50 cents in debt for every dollar in equity. In other words, their target capital structure is 1/3 debt and 2/3 equity. So they're just giving you the weights. So now we need our values. 2/3 is our equity portion, 1/3 is our debt portion. They took the mean of these two, 10.8 and 10.88, and got 10.84. So 2/3 times 10.84, 1/3 for the debt times the debt. They haven't asked for the debt portion. But it says here that the cost of debt is 9% and the tax rate is 21%. So we'll plug that in, 9% and 1 minus 0.21. Multiply these two, multiply these 3, and add them up, and you get 9.6%. Suppose there were flotation costs. I'm not going to have you do this because I don't like the way it's done in the text. I like the way that I showed it, and I'm not going to ask that either. So let's just punt on this one. Now let's go through a couple of problems that are in the previous edition of this book. They look very much like the same problems in the current edition, but the numbers are different. That's what publishers typically do from one edition to another, and I think it's really to cause people to have to buy a new edition instead of buying the old edition. But you know, that's just the way it's done. So this says this company has 8 million shares of common stock outstanding. Current share price is $73. Book value is $7. They have 2 bond issues outstanding. First one has a face value of $85 million. By the way, this is reproduced. You can print this out, wherever you when you pulled up this video, there was a link to this item and to the previous one actually. First bond issue has a face value of 85 million. I'm going to circle things. So we've got 8 million shares. Share price is 73. Let's go with red. The book value per share is 7. Company also has 2 bond issues outstanding. The first bond issue has a face value of 85 million and a 7% coupon and sells for 97% of par. The second one, face value of 50 million, 8% coupon, and sells for 108% of par. First issue is in 21 years, matures in 21 years, and the second one in 6 years. What are the company's capital structure weights on a book value basis? So, book value. Okay, book value equity is the book value per share times the number of shares, and the book value of the debt is the face value of the company's debt. So, the book value of equity is there are 8 million shares, and the share price is $7. So, 8 million times 7, 56 million. The book value of debt, well, you have 2 issues. One is 85 million, the other is 50 million. So you add them up and it's 135. So the total value of the company would be the value of the equity plus the value of the debt. So we're going to add those up. So that V for value is the sum of these two, 191 million. And so the weights would be 56 million divided by 191 million, and 135 million divided by 191 million. But what this is showing here in this solution is that once you get the weight for one of them, you can just subtract 1 minus the weight for that one to get the weight for the second one. So 56 over 191 is 29.32%. 135 over 191 would be 70.68%. The next question, what are the company's capital structure weights on a market value basis? Okay, so this is what we're going to be most concerned with on our exams. A market value basis, we have 8 million shares, and the current price is $73. I'm not sure if I said that correctly earlier. This was the book value per share. The $7 that was used up here, right here, was book value. And the market value is $73. So 8 million times 7 was when we were looking at book value per share. So back to this, 8 million shares at $73, which is our current share price, is 584 million. Now, for the market value of the debt, we have one of them is selling for 97% of par, and it's a face value of 85 million. So 97%. No, you can't see that, can you? I'm going to have to back out of this, and it's going to make it hard for you to see, but you should have reproduced it so you can see it up close yourself. So apologize for that. So I'm going to start over on this part then. So we had 8 million shares, $73 per share, 8 million, 73, 584. Now for the bonds, we have one bond that's at 85 million in face value, and it's selling for 97% of par. So if it's selling for 97% of par, then the market value would be 97% of 85 million. And that's what this is showing here. And for the other issue, it's selling for 108% of par, and it has a face value or par value of 50 million. So 1.08 times 50 million. And multiply those two out, add them up, and this says that the market value of the debt is 136,450. So the total value then of the company would be the sum of the market value of the equity and the market value of the debt. And so this is the sum. And then there's only one more step, and that is we have to divide the 584 by the 720, and that gives us an equity percentage of 81.06%. And since there are only two, we could say 1 minus this one to get the debt version, or we could just say 136,450 divided by 720,450, and that would have given us the answer. Now I'm going to be sort of going back and forth a little bit here so you can, because this next problem relies on the previous one. In problem 12, this one, suppose the most recent dividend was $3.90 and the dividend growth rate is 6%. Assume that the overall cost of debt is the weighted average of that implied by the two outstanding debt issues. Both make semi-annual payments. The tax rate is 35%. What is the company's weighted average cost of capital? Okay, so this sounds like it gets a little involved, but just kind of step by step. First, what's the cost of equity? Well, they don't give us any information about beta, so we have to assume, since they do give us information about the dividend, and the current share price and the growth rate, we can go ahead and let's see, growth rate is somewhere over here. I don't see it. Oh, here's the growth rate, 6%. So we've got D1 over P0 plus G, and D1 is the most recent dividend times 1 plus the growth rate, which is 1.06, divided by 73, add the growth rate, 0.06, and we get 11.66%. Now, we're going to get a weighted average of the yield to maturity on the two different debt issues. And so this one becomes, actually you think debt's kind of easy, but it becomes more complicated. So we had, on the first one, we'll go kind of step by step, was a 7% coupon. And this specifies that they were semi-annual payments. So if it's a 7% coupon, that means it pays 35 every 6 months. So let me see if I can get this over here a little bit. So the bond price of the first one was 97 or 970. So 970, change signs is the present value. 1,000 would be the future value. This is semi-annually, so 35 at 7%, 7% coupon over here, but it's semi-annual, so it's really 3.5%, and 3.5% of 1,000 face value is 35, so 35 will be our payment. And the number of years is equal to 21, it says over here, 21 years, but that's years. We need semi-annual payments, so we'll double that to 42. So 42 is our N, and now we have recall N, recall present value, recall payment, recall future value, and now I'm going to compute the I, and it comes up to 3.64, and I'm going to multiply that by 2 because it's semi-annually. We need to convert it to annual, and that gives me 7.28, which is this one here. Now we'll go for the other one, and it's selling for 108%, 108% of par, and it matures in 6 years and has an 8% coupon. So 1,000 is our future value, and 1,080 change signs is our present value. It's an 8% coupon, so half of that would be 4%, so 4% of 1,000 is 40, so 40 is our payment, and our number of years, I think, is 6. Only this is semi-annual, so we're going to double it. 12 is our N. Compute IY, and it's 3.187. Now we're going to multiply that by 2, and that equals 6.37. So what they're showing here is we're going to figure a weighted average of these two debt issues. And so we've got 97 times, this is 85 million divided by 136,450,000, and that's the numbers that we got over here. So the sum of these two was on this previous page, and it was right here. So that's the total market value of the debt. You know, the Kingsmen were very persistent. So the weight in one of the debt issues is just its market value times the total market value of the two, and that's 60.43%. And then the other one's market value is 1.08, because it's selling for 8% above par, times 50 million, and divide it, and so that's its weight. And now we're going to do a weighted average cost of debt, just like we do weighted average cost of capital, and the tax rate is 35%. So we're going to take the weight of 1 times its rate. So here's the weight, 60.43%, times its rate, which is 7.28. So we multiply that out, and then we're going to multiply out the 39.57% times the 6.37%, and then we're going to multiply all of that by 1 minus the tax rate, because it's tax deductible, and we get 4.5%. And finally, we're going to calculate the weighted average cost of capital. And in doing that, we're going to say 81.06%. Uh-oh. I think I was off the page there. For that one, we're going to take those weights that we calculated on the previous page, 81.06 and 18.94, and they're over here now. So we're going to take the weight in equity times the return on equity, and the return on equity is 11.66, so 81.06% times 11.66. And we're going to add that to 18.94, which is this weight over here, 18.94, times the 4.5% cost of debt. Multiply that stuff out, add them up, and we get 10.31%. There's one other thing I wanted to do, and that is just address this problem here, which is one of your homework problems, because sometimes this causes a little bit of grief. It doesn't look very good. Let me see if I can a little bit more light. I don't know if that's better or worse. So what's expected here is that you use the information given to you, which is we have a risk-free rate. It says T-bill rate, but it's the risk-free rate is 4%, and the expected return on the market is 11%. So this is given to you as a security market line type problem. And we know that the return on equity, required return on equity, when it's put this way, is the risk-free plus the return to the market minus the risk-free times the beta. Now, your book tends to put beta over here. I prefer it to be over here, but that's personal preference. They have been saying, okay, the market risk premium, and just giving you the number that's the difference between these two. That's not what they've done here. What they've done is say that this is 4%, and the expected return to the market is 11%, and the risk-free rate is 0.04% again. And the betas are different for each one of these. And so what you need to do is substitute in this same structure each one of these individual betas and calculate what the required rate of return would be for each one of these. And ultimately, you're going to compare that required rate of return to the internal rate of return that that project would generate. And it needs to have an internal rate of return that's larger than what you would calculate here. So this is going to be your required rate of return, and you're going to compare your IRR to that required rate of return, not to the weighted average cost of capital. And in this problem, they ask you which of these should be accepted and which should be rejected, essentially. And really, it's like this graph here on page 476. So you're trying to figure out, relative to the weighted average cost of capital and the security market line, you're trying to figure out, is something above the security market line? And they're trying to get you to understand that it's possible that something could be, like B here, could be above the weighted average cost of capital, which sounds good, except because of B's extra risk, it actually has to be higher than that. It has to be higher than the security market line, or at least on the security market line. So it needs to be greater than 16%. Well, that's the same thing that you're doing in this problem, is you're comparing this stuff to the cost of where are we here? Here they're showing the expected return to the market. The firm's 11% cost of capital. And they emphasize that it's an all-equity firm, so you don't need to worry about any of the leverage aspect. So both the market return and the company's cost of capital are 11%, and you need to compare each one of these individual rates of return based on requirements from the security market line to the IRR, and then follow through for the rest of this. Okay, that's all I wanted to talk about. I will, however, make another video later in the week that will address the exam.